In the vast cathedral of the cosmos, where countless stars flicker like ancient candles against the velvet blackness, a haunting silence persists. For centuries, humanity has gazed upward, captivated by the brilliance of the night sky, and asked the most profound question: where is everybody? This is the timeless enigma known as the Fermi Paradox, a riddle wrapped in cosmic mystery. But tonight, that silence begins to stir with revelations that challenge everything we believed about life's place in the universe. Welcome to the Sleep Lab, your sanctuary, where the universe's deepest secrets unfold in slow, poetic stories crafted to soothe your mind and ignite your wonder. Recent discoveries are peeling back the veil on the cosmic silence, revealing hidden oceans beneath distant ice moons, mysterious radio signals that dance on the edge of comprehension, and subtle whispers woven into the very fabric of space-time. Over the next 2 hours, we will drift through 15 extraordinary mysteries that transform the Fermi Paradox from a question into an invitation to dream deeper, to wonder further, and to embrace the silent beauty of the cosmos. Let your breath slow and your thoughts settle as the Sleep Lab guides you gently through the vast, breathtaking tapestry of space and time. Close your eyes and surrender to the cosmic lullaby waiting just beyond the stars, as the universe softly reveals its secrets and the answer to our loneliness may quietly unfold in the dreamscape of night. In the velvet darkness that cradles our world, 10,000 silent companions spin through the cosmic deep. They turn their faces toward distant suns, bathed in alien light, yet they speak no word to us across the void. Night after night, they dance their eternal waltz through space, and night after night, we strain our ears for the faintest whisper of greeting. But the universe holds its breath, and in that breath lies a mystery that haunts the dreams of those who dare to listen. There was a time, not so long ago, when Earth seemed precious in its solitude. Our sun appeared unique, our world a singular jewel suspended in an ocean of emptiness. The stars were distant candles, beautiful but barren, offering nothing but cold light to warm our wondering hearts. Astronomers of generations past gazed upward with instruments crude by today's measure, seeing only points of brightness scattered like salt across black velvet. They dreamed of other worlds, but dreams were all they possessed. Then came the awakening. In the closing decades of the 20th century and the dawning years of the 21st, humanity's eyes grew sharper. Telescopes like patient sentinels began to taste the light of faraway suns, sipping photons that had traveled for years to reach our waiting instruments. They learned to detect the subtle dimming of a star as an unseen world passed before it, a cosmic eclipse performed for audiences of one. Each dimming became a revelation, each shadow a new world stepping into the light of discovery. The tally began small, a handful of worlds, strange and wonderful, orbiting their parent stars in ways that defied our earthbound expectations. Giants of gas swept close to their suns in days where our Earth takes a year. Rocky worlds, scorched and frozen, traced impossible paths through the darkness. Each discovery was a small miracle, a whisper from the cosmos that said, "You are not alone in having worlds." But whispers became a chorus, and the chorus became a symphony of discovery. The Kepler Space Telescope, launched like a silver prayer into the infinite, began its patient watch. For years it stared unblinking at a patch of sky no larger than a human hand held at arm's length, counting shadows and measuring the subtle dance of light and darkness. What it found changed everything we thought we knew about our place among the stars. Thousands of worlds revealed themselves. Thousands. The universe, it seemed, was not barren, but fertile beyond imagining. Rocky planets like our own spun in that precious zone where water might pool and life might stir. Some circled red dwarf stars that burn with the patience of eternity. Others danced around sun-like stars that paint their worlds with familiar golden light. The cosmos suddenly felt crowded with possibility, thick with potential homes for minds that might think and hearts that might dream. Yet as the catalogue of worlds grew, so too did the mystery that would come to haunt our midnight thoughts. For all the planets discovered, all the worlds that might harbour oceans and atmospheres and the chemistry of life, the universe remained as silent as it had ever been. No radio signal carried greetings across the light years. No pattern in the starlight spelled out messages of welcome or warning. The more worlds we found, the deeper grew the riddle of their silence. Scientists began to speak in hushed tones of the Fermi Paradox, named for a physicist who asked the simplest and most profound of questions. Where is everybody? If the universe teems with worlds, if the ingredients for life are scattered like seeds on cosmic winds, then why do we sit alone with our questions? The mathematics seem to suggest that intelligence should be common, that civilizations should rise like flowers in spring acai. Ross the galaxy. Yet the flowers, if they bloom at all, bloom in perfect silence. Some nights, when the data streams in from our telescopes and the computers tally another batch of distant worlds, the astronomers who tend these digital harvests pause in their work and stare up at the stars. They know now that those points of light are not merely suns, but likely the centers of entire families of worlds. Some of those worlds may be blue and green like ours, wrapped in clouds and kissed by gentle rains. Some may cradle vast oceans beneath shells of ice, where strange creatures swim in darkness older than complex life on Earth. The James Webb Space Telescope, that golden eye we've placed at the edge of darkness, now tastes the very breath of these distant worlds. It reads the chemical signatures written in their atmospheres, looking for the telltale signs of water vapor, oxygen, methane, the gases that might whisper of life. Each spectrum it captures is like reading a letter written in an alien language, searching for familiar words that might spell home, or life, or hello, but the letters remain cryptic, the messages unclear. Atmospheric chemistries that might suggest biology dance always at the edge of certainty, never quite crossing the threshold into confirmation. We find what might be signs of life, but might equally be the complex chemistry of lifeless worlds. The universe seems to delight in keeping its secrets just beyond our grasp, offering tantalizing hints while withholding the final revelation. In the quiet hours before dawn, when the last observations of the night are complete and the telescopes turn their faces away from the stars, there comes a moment of profound wondering. We have found the worlds. They are there, spinning in their billions around their appointed suns, many of them bathed in the gentle warmth that might nurture life. Yet they remain as distant and unreachable as ever, islands of possibility in an ocean of space and time. Kipu. Perhaps the silence itself is the answer. Perhaps consciousness is rarer than we dared imagine, a cosmic accident so unlikely that it occurs only once in a trillion worlds. Or perhaps intelligence blooms throughout the galaxy, but chooses silence, either from wisdom or fear. Perhaps civilizations rise and fall like waves on a beach, leaving no trace of their passing by the time their light reaches our waiting eyes. As you settle into sleep tonight, remember that above your dreams, 10,000 worlds spin through darkness, some bathed in alien sunrise, others locked in eternal night. They are our cosmic siblings, born from the same stellar furnaces that forged our own Earth, yet they remain strangers across the vast. Their silence is not empty but full of mystery, full of possibility, full of questions that may outlive the very stars that warm them. In that silence, perhaps, lies the deepest poetry the universe has to offer, the knowledge that we are both utterly alone and surrounded by infinite possibility, citizens of a cosmos that is both crowded with worlds and empty of voices, rich in promise and faithful in its secrets. In the frozen reaches where sunlight fades to nothing more than the memory of warmth, ancient waters move in darkness deeper than any earthly night. beneath shells of ice thick as mountains, oceans older than our continents roll and whisper secrets that no human ear has heard. Here, in the shadow-wrapped moons that dance around the giant worlds, lies perhaps the universe's most haunting riddle. Can life kindle its flame where no sun has ever shone? The tale begins not with flesh and blood explorers, but with metal wanderers sent to taste the void. In the year when disco still pulsed through Earth's nights and Cold War tensions froze human hearts, two silver messengers called Voyager lifted themselves on pillars of fire and began their endless journey toward the edge of forever. Their mission was simple in scope yet infinite in ambition, to visit the giant worlds that guard our solar system's outer reaches and send back word of what they found dancing in that cosmic darkness. For years, these mechanical pilgrims sailed through emptiness, their cameras sleeping, their instruments patient as monks in meditation. Then came the first revelations, transmitted across billions of miles of space in whispers of radio waves. Jupiter's moons, it seemed, were not the dead, cratered wastelands that astronomers had imagined. Europa, that ice-wrapped pearl, gleamed with a surface cracked and reformed, sculpted by forces moving beneath its frozen skin. The patterns etched across its face spoke of an ocean hidden below, vast and dark and unimaginably deep. But it was Saturn's distant child, Enceladus, that would offer the first true miracle. When Cassini, Voyager's spiritual heir, finally reached the ringed planet's court of moons decades later, its instruments detected something that made scientists across Earth pause in wonder. From the south pole of this small, brilliant world, guys, airs of ice and vapor erupted into space like the breath of some sleeping leviathan. The plumes rose hundreds of miles above the surface before falling back as snow, and in those crystalline exhalations, Cassini tasted salt. Salt. The word carried implications that rippled through the halls of science like stones thrown into still water. For salt speaks of oceans, of water that has touched rock and dissolved the minerals of worlds. The geysers were not mere ice fountains, but windows into a hidden sea, a body of water larger and deeper than any ocean on Earth, kept liquid by the gentle fire of tidal forces that knead and warm Enceladus's heart. The probe's instruments, sensitive as a lover's touch, detected more than salt in those rising plumes. Organic molecules danced in the spray, complex carbons that on Earth serve as the building blocks of life. Simple compounds that, in the right conditions, might link and grow and perhaps even dream. The implications hung in the scientific community, like incense in a cathedral. Here was not just water, but water rich with the chemistry that life requires. Europa, too, began to reveal its secrets under the patient gaze of telescopes and the fleeting visits of robotic explorers. Its ice shell, once thought solid and uniform, showed signs of convection and turnover. Fresh ice rose from below, while older surface material sank back toward the hidden ocean, creating a circulation that might carry oxygen from the surface down to the dark waters beneath. Mathematical models painted pictures of a sea twice as deep as Earth's deepest trenches, containing more water than all our planet's oceans combined. Other moons joined the chorus of revelation. Titan, Saturn's largest child, revealed lakes of liquid methane and ethane beneath skies thick with organic haze. Ganymede and Callisto, Jupiter's ice-wrapped giants, showed magnetic signatures, suggesting saltwater oceans trapped between layers of ice and rock. Even distant Pluto, demoted from planethood but not from wonder, might harbor a liquid sea beneath its frozen heart. The implications settled over humanity like a vast, silent snowfall. Our solar system, once thought to contain liquid water only in the narrow band where Earth orbits, suddenly revealed itself as an archipelago of hidden oceans. Worlds that had seemed barren and lifeless when viewed through telescopes now pulsed with the possibility of biology, of chemistry complex enough to support the dance of living systems. Yet with possibility came frustration. The same ice that protected these buried seas from the vacuum of space also shielded them from our prying instruments. No camera could peer through miles of frozen barrier to glimpse what swam in those dark depths. No microphone could catch the sound of currents moving through alien waters. The oceans remained as hidden as they had been before we knew of their existence, their secrets locked away like manuscripts in a tomb. Scientists began to dream of missions that might pierce the ice, sending robotic submarines through the shell to taste those hidden waters directly. They sketched plans for nuclear-powered probes that could melt their way down through Europa's crust, for submarines that might swim in Enceladus's sea, for instruments sensitive enough to detect the chemical signatures of life in a handful of geyser spray. But the technical challenges loomed like mountains, and the years stretched ahead before such visions might become reality. In the meantime, the hidden oceans continued their eternal circulation, their waters mixing and moving in patterns older than complex life on Earth. If creatures swam in those depths, they would know only darkness, their world lit perhaps by the glow of volcanic vents or bioluminescent chemistry. They would taste only salt and minerals dissolved from their rocky boundaries, never knowing the sweetness of rain or the warmth of sunlight on water's surface. The thought haunts those who study these distant seas. Could life have learned different lessons in the darkness? Could biology have found pathways to complexity that Earth's sunlight-driven systems never explored? The chemistry seemed promising. Energy from radioactive decay and tidal friction, organic compounds delivered by impacts or synthesized in deep-sea vents, liquid water with all its power to dissolve and transport and enable the intricate dances of biochemistry. Yet the silence persists. No signal emerges from the depths, no sign of intelligence or even simple life. The geysers of Enceladus spray their tantalizing hints into space, but those hints remain cryptic, speaking in a chemical language we can barely decipher. The oceans roll on in their darkness, keeping their secrets as faithfully as any tomb. As sleep draws near and consciousness begins its own dive into darkness, consider the waters that move beneath alien ice, warm and salty and patient as the cosmos itself. In those depths, perhaps, life has already learned to thrive without stars, to build complexity from chaos, to sing songs that no ear will ever hear. Or perhaps they remain empty, vast cathedrals of water waiting for the first spark of biology to kindle and grow. Either way, they remind us that the universe's greatest mysteries often lie not in the light of distant stars, but in the darkness that cradles worlds, hidden and deep and full of infinite possibility. In the cathedral of cosmic static, where 10,000 radio frequencies whisper and wail like souls in purgatory, one voice cried out for exactly 72 seconds and then fell forever silent. It spoke in the language of hydrogen, that most ancient and abundant of elements, its message encoded in electromagnetic poetry at a frequency so specific, so meaningful, that it could not have been an accident. Yet when the scientists turned their instruments back to catch that voice again, they found only emptiness, only the endless hiss of the universe breathing in its sleep. The year was 1977, and Earth was wrapped in the soft malaise of disco and détente, unaware that it was about to receive what might have been the most important telephone call in human history. At Ohio State University, a radio telescope called Big Ear turned its mechanical face toward the constellation Sagittarius, listening with infinite patience to the symphony of radio waves that bathe our planet every moment of every day. Most of what it heard was the background noise of creation itself, the afterglow of the Big Bang, mixed with the radio chatter of distant galaxies, pulsars spinning their lighthouse beams across the void, and the electromagnetic pollution of our own civilization. Jerry Amon worked the night shift in that temple of electronic ears, a volunteer in humanity's greatest act of hope and desperation, the search for extraterrestrial intelligence. Night after night, he and his colleagues sifted through computer printouts thick as phone books, scanning columns of numbers that represented the intensity of radio signals arriving from specific patches of sky. Most readings showed only the cosmic background, a gentle static that registered as ones and twos on their scale. Occasionally, terrestrial interference would spike the numbers higher, but these signals bore the messy signature of human technology. But on August the 15th, as Ayman reviewed the printout from 3 nights before, his eyes fell upon a sequence that made his heart skip. 6EQUUJ5. In the telescope's crude alphanumeric code, this represented a signal 30 times stronger than the background noise, rising and falling in a precise pattern that matched exactly what the telescope would record if it had detected a transmission from a fixed point in space. The signal had lasted exactly 72 seconds, the precise amount of time Big Ear took to sweep across any given region of sky as Earth's rotation carried the telescope's beam through the heavens. Ayman grabbed a red pen and circled the anomalous sequence, scrawling "Wow" in the margin, a moment of scientific excitement that would give the signal its eternal name. For here, encoded in these 6 simple characters, was something that defied easy explanation. The signal came from the direction of the constellation Sagittarius, near a star group called Chi Sagittarii, from a region of space empty of known radio sources. Its frequency of 1420, 456 MHz was no random choice, but the signature of hydrogen atoms flipping their electron spins, a universal constant that any technological civilization would recognize as meaningful. This was the frequency that scientists had predicted alien civilizations might use as a cosmic calling card. Hydrogen is the most abundant element in the universe, and its radio signature at 1420 MHz represents a fundamental constant of physics. Any species that had mastered radio astronomy would know this frequency, would understand its significance as a natural reference point in the electromagnetic spectrum. It was, in the words of one researcher, the cosmic equivalent of a telephone ringing in a universal language, word of the wow. Signals spread through the scientific community like ripples in still water. Within days, radio telescopes around the world turned their mechanical eyes toward Chi Sagittarii, straining to catch an echo of that mysterious transmission. But the stars remained silent. Where once a voice had called across the light years, now there was only the familiar whisper of cosmic background radiation. The signal, whatever it had been, was gone as suddenly and completely as it had arrived. Theories bloomed like night-flowering cereus in the minds of scientists and dreamers. Perhaps it had been a greeting, a cosmic hello transmitted by a civilization that had detected some sign of technology from Earth. Radio and television broadcasts had been leaking into space for decades by 1977, spreading outward at the speed of light to announce humanity's presence to any listeners with sensitive enough equipment. Maybe someone, or something, had finally heard us and decided to respond. Others suggested it might have been a lighthouse beacon, a navigation signal transmitted by a star-faring civilization for their own vessels traveling between the stars. Such a beacon might sweep across space in a regular pattern, touching Earth's vicinity only briefly before moving on to illuminate other regions of the galaxy. We had simply been lucky enough to intercept one pulse from a transmission not meant for us. More skeptical voices proposed terrestrial explanations, a military satellite with a malfunctioning transmitter, a secret experiment in atmospheric research, even the reflection of Earth-based signals off debris in space. But none of these theories could fully explain the signal's characteristics, its precise frequency, its duration, its apparent origin from deep space, its complete absence before and after that single detection. As years turned to decades, the WOW signal became nothing more than a scientific anomaly. It transformed into a modern legend, a digital ghost story told in the halls of observatories and the pages of astronomy textbooks. Graduate students learned its story like a cautionary tale about the challenges of SETI research. Science fiction writers wove it into stories of first contact and cosmic communication. And always in the background, radio telescopes continued their patient vigil, hoping to catch that voice again. The search intensified with better technology and more sensitive equipment. The region of Chi Sagittarii was observed hundreds of times with increasingly sophisticated instruments. Radio telescopes in multiple countries coordinated their observations, creating a global net designed to catch any repeat performance, but the signal never returned. Whatever intelligence or phenomenon had spoken for those 72 seconds in August 1977 had apparently said all it intended to say. Some nights, when the radio telescopes sweep their beams across that same patch of sky, the operators pause and imagine what might have been. Perhaps somewhere in the darkness between the stars, another civilization is waiting patiently for a response that will never come. Perhaps they transmitted their greeting, and receiving only silence, concluded that Earth was uninhabited after all. Perhaps they moved on to other star systems, other potential homes for intelligence, leaving us alone with our regrets and our wondering. Or perhaps the wow signal was never meant for us at all. Perhaps we simply eavesdropped on a conversation between distant worlds, catching a fragment of interstellar communication, like a child holding a seashell to her ear and hearing the ocean's whisper. The message, if message it was, might have been as mundane as a weather report or as profound as a declaration of love, forever lost in translation across the vastness of space and time. As you settle into the quiet darkness of night, remember that somewhere in the constellation, Sagittarius, a patch of space holds the memory of humanity's most tantalizing moment of possible contact. The signal that emerged from that region for 72 seconds in 1977 remains unexplained, a cosmic riddle written in the universal language of hydrogen and mathematics. It reminds us that the universe is full of voices we don't understand, conversations we can barely detect, and messages that arrive without warning and depart without explanation. Perhaps tomorrow night, another telescope will catch another impossible signal, and perhaps this time we'll be ready with the right questions and the wisdom to understand the answer. Until then, we listen, and we dream, and we remember the echo that vanished. In the thin veils that shroud distant worlds, secrets drift like whispers on an alien wind. Each planet wears its atmosphere like a silk scarf, gossamer thin yet heavy with the story of what lives or has lived upon its surface. From across the light years, we taste these planetary breaths through instruments more sensitive than a lover's touch, reading chemical poetry written in molecules too small to see, yet vast enough to change everything we thought we knew about loneliness in the cosmos. High above Earth's own breathing atmosphere, beyond the blue dome that cradles our dreams, a golden eye opens in the darkness. The James Webb Space Telescope unfolds like a metallic flower, its mirrors polished to a perfection that would make angels weep, each surface capable of catching light that has traveled for billions of years to reach this moment of revelation. This is our newest prophet, our mechanical mystic sent to read the chemical scriptures inscribed in starlight and planetary shadow. The telescope turns its ancient gaze toward worlds that circle other suns, worlds whose names are mere catalogue numbers, but whose mysteries run deeper than any earthly ocean. K2 18b, HD 209458b, WASP 96b. Each designation marks a place where alien skies stretch over alien landscapes, where weather patterns unknown to Earth paint clouds across horizons no human eye will ever see. Yet through the patient alchemy of spectroscopy, we can taste what fills those distant heavens, can sample the very air of worlds we will never touch. The process unfolds like a ritual older than writing, though it employs mathematics that would have seemed like magic to our ancestors. When a planet passes between its star and our waiting instruments, the starlight must filter through the planet's atmosphere to reach us. Different molecules absorb different wavelengths of light, each leaving its signature in the spectrum like fingerprints pressed into warm wax. Oxygen steals away the red. Water vapor devours the infrared. Methane swallows specific frequencies with a hunger that speaks of carbon chemistry and the complex dances that carbon enables. The first readings arrive like messages in bottles cast upon cosmic seas. Scientists huddle around computer screens displaying graphs and spectra, their eyes searching for patterns that might spell out the presence of something extraordinary. Most often they find the expected signatures: hydrogen and helium in the atmospheres of gas giants, carbon dioxide and nitrogen in the thin air of rocky worlds too close or too far from their parent stars to harbor the complex chemistry of life. But sometimes, in the quantum whispers of filtered starlight, something unexpected emerges, a spike of oxygen where none should be, methane in concentrations that suggest constant replenishment, water vapor dancing with other molecules in ratios that make atmospheric chemists pause and wonder. These are the moments when the machinery of science touches the realm of dreams, when data becomes prophecy and spreadsheets transform into scripture. Consider the story written in the atmosphere of K2-18b, a world twice Earth's radius orbiting a red dwarf star 124 light-years away. Through the James Webb telescope's patient observations, scientists detected not just water vapor in its atmosphere, a discovery wonderful enough, but also methane and carbon dioxide in concentrations that sparked debates in conference halls and kept researchers awake through long nights of speculation. The chemical signatures suggested a world where complex atmospheric chemistry might be painting stories we can barely begin to read. Yet reading these atmospheric manuscripts requires the patience of monks and the skepticism of detectives. Every spike in a spectrum might be life, or it may be geology. Every unexpected ratio might signal biology, or it might reveal atmospheric processes that exist nowhere in our solar system's family of worlds. The universe delights in offering false prophets and chemical mirages, signatures that tantalize with the possibility of life, but fade under closer scrutiny into the mundane workings of planetary physics. Oxygen, that breath of Earth's green revolution, appears in alien atmospheres with meanings that shift like shadows at twilight. On our world, free oxygen exists only because billions of years of photosynthesis have pumped it into the air faster than chemistry can consume it. But oxygen might arise through other means on other worlds, through the breakdown of water vapor in upper atmospheres, through the outgassing of rocks rich in oxides, through processes that have nothing to do with the patient work of living cells converting sunlight into sugar and waste oxygen into the gift of breath. Methane poses its own riddles, equally seductive and equally ambiguous. On Earth, most methane comes from living sources: bacteria in swamps, microbes in the guts of animals, the decay of organic matter in environments where oxygen fears to tread. But methane can also seep from the deep places of worlds, released by geological processes that grind and heat and transform rock into gas. A methane signature might be the chemical signature of alien life, or it might simply be the planet's way of clearing its geological throat. The debates unfold in scientific journals and conference rooms with the intensity of theological disputes. Each new spectrum brings fresh evidence to examine, new patterns to interpret, new possibilities to consider, and ultimately, often, to set aside as inconclusive. The atmosphere of WASP 96b reveals water vapor and clouds. HD 209458b shows sodium and potassium. Each discovery adds another word to our growing vocabulary of planetary atmospheres, but the sentences we try to form from these words remain incomplete, their meanings hovering forever just beyond our grasp. As scientists speak in careful, conditional phrases, hedging their interpretations with the learned caution of explorers who have been disappointed before. Could suggest biological processes, might indicate atmospheric disequilibrium, consistent with but not proof of. The language of possibility dances around the edges of confirmation like a shy lover afraid to speak the words that might change everything. Meanwhile, the telescopes continue their patient vigil, their instruments growing more sensitive with each passing year, their ability to dissect atmospheric composition approaching levels that would have seemed impossible mere decades ago. Future missions promise to push these capabilities even further, to read the chemical stories of Earth-sized worlds orbiting sun-like stars, to detect biosignatures so subtle and specific that they could only arise from the intricate chemistry of life. Yet even as our instruments grow more powerful, the fundamental challenge remains unchanged. We are trying to recognize the signs of life as we do not know it, to interpret chemical signatures that might arise from biological processes unlike any that exist on Earth. We search for the familiar: oxygen, methane, water vapor in unlikely combinations. while remaining blind to possibilities we cannot imagine. Perhaps alien life writes its stories in atmospheric chemistry, using an alphabet we have never learned to read. As the night deepens and consciousness begins its own slow fade into dreams, remember that somewhere among the stars, alien atmospheres are breathing their chemical secrets into the darkness. Each exhalation carries molecules that might spell life or geology or mystery in languages we are only beginning to understand. The golden eye of our space telescope continues its patient reading of these atmospheric manuscripts, searching for the chemical signatures that might finally answer the question that haunts our midnight thoughts. Are we alone? The answer, if it comes, will arrive not as a voice from the stars, but as a whisper in the wind of distant worlds, in the vast cathedral of space, where 10 billion stars burn like votive candles in an infinite darkness. Something moves between the lights that makes even the boldest civilizations whisper. They say the galaxy is not empty but full of minds that have learned the first and most terrible law of cosmic survival. To speak is to die. To shine is to be hunted. To announce your presence is to paint a target upon your world that will never fade. In this dark forest of stars, every civilization that has survived long enough to contemplate the void has learned to hold its breath. The theory emerged not from telescopes or radio dishes, but from the fevered imagination of those who dared to think like predators among the stars. It began as a thought experiment, a philosophical puzzle wrapped in the language of game theory and evolutionary psychology. But as the years passed and our instruments grew more sensitive, as we mapped more worlds and detected more silence, the dark forest theory began to feel less like speculation and more like prophecy, a cosmic horror story that explained why the universe remained so terrifyingly quiet. Picture, if you will, a forest at midnight. Ancient trees rise like pillars in the darkness, their canopies so thick that no starlight penetrates to the forest floor. In this absolute blackness, creatures move with careful steps, their breathing shallow, their hearts beating in rhythms tuned to silence. Each knows that others hunt in the darkness, predators with senses sharp enough to detect the smallest sound, the faintest trace of warmth, the briefest flash of light. In such a forest, the wise hunter moves like a ghost, kills like a shadow, and above all, never announces his presence to the night. Now expand this forest to galactic proportions. Replace the trees with star systems, the creatures with civilizations, the darkness with the vast emptiness between worlds. In this cosmic hunting ground, the rules remain the same, remain hidden, remain silent, remain alive. Any species that broadcasts its location, through radio signals, through the infrared signatures of industrial civilization, through the spectroscopic evidence of atmospheric manipulation, becomes prey for those who have mastered the art of interstellar predation. The logic unfolds with the inexorable weight of natural law. Resources in the galaxy are finite, even if they appear abundant on human timescales. Habitable worlds are precious jewels scattered across an ocean of uninhabitable rock and gas. As civilizations expand and their hunger for energy and materials grows beyond what single star systems can provide, they must look outward, must compete for the galaxy's riches. But direct negotiation between species separated by light years and possibly millions of years of evolutionary divergence becomes impossible. How can you trust a mind that evolved under an alien sun, that thinks thoughts shaped by chemistry and physics, unlike your own? The mathematics of survival offer only one solution. Strike first, strike silently, strike completely. If you detect the signs of another civilization, the regular pulses of their communication networks, the chemical signatures of their industrial processes, the gentle modification of their star's light as they harvest its energy, you must assume they will eventually detect you as well. In a universe where the first to act enjoys overwhelming advantage, where interstellar distances make defense impossible and retaliation meaningless, the rational choice becomes genocide performed at the speed of light. Perhaps somewhere in the constellation Centaurus, a civilization older than Earth's complex life detected the first radio broadcasts leaking from our atmosphere. Perhaps their philosophers and strategists gathered in halls we cannot imagine, studying the spectroscopic evidence of our industrial revolution, the growing signatures of our technology, the clear signs of a young species beginning to reach toward the stars. Perhaps they calculated the time it would take us to develop interstellar travel, weighed the potential threat we might someday pose, and quietly began to prepare their response. The weapons of such predators would be subtle beyond our imagination. Not the crude nuclear fire of our primitive arsenals, but tools that work with physics itself, relativistic projectiles that announce themselves only with the death they bring, self-replicating machines that could turn an entire star system into raw materials for further expansion, or simply the patient redirection of asteroids and comets into trajectories that would sterilize a world while appearing to be natural catastrophes. In this dark forest of the galaxy, Earth's behavior over the past century appears almost suicidally naive. We have shouted our presence across the electromagnetic spectrum, beamed high-powered signals toward nearby star systems, and even launched physical messages aboard spacecraft that carry maps showing exactly where we can be found. If the dark forest theory holds true, we have violated every principle of cosmic survival, announcing ourselves to any hunters patient enough to listen. Yet our satellites continue their vigil, scanning the skies for the very signals that, according to this theory, no intelligent species would ever dare to transmit. The search for extraterrestrial intelligence proceeds with the assumption that other civilizations might be as communicative as we have been, as willing to risk their survival for the chance of contact. But if the dark forest theorists are correct, our radio telescopes are not searching for messages from potential friends. They are attempting to eavesdrop on the final screams of species too young to know better. The paranoia inherent in this vision infects even our most optimistic calculations. Every unexplained astronomical phenomenon becomes suspect. Was that gamma-ray burst truly a natural stellar explosion, or the signature of a civilization being systematically obliterated? Do those regular pulses from distant pulsars represent the lighthouse beams of rotating neutron stars, or the hunting calls of predators announcing their territories to potential rivals? Even our own sun's stability becomes questionable. Could those solar flares be natural magnetic eruptions, or evidence that someone, somewhere, has begun the slow process of weaponizing our star? The silence of space, once mysterious, now carries the weight of terrified whispers. Perhaps the galaxy teems with civilizations, each one crouched in electronic darkness, their cities shielded from detection, their communications tightly beamed and heavily encrypted. Perhaps millions of species have achieved the technology necessary for interstellar communication, but dare not use it, knowing that the first to speak in this cosmic forest becomes the first to die. In the deepest hours of night, when our own world turns its face away from the sun and our radio telescopes sweep their mechanical gazes across the star-drunk sky, consider the possibility that we are not alone, but surrounded by minds ancient and terrible, by civilizations that have survived the dark forest only by becoming predators themselves. Our innocence may be our death sentence, our curiosity the bait that draws the hunters closer. Perhaps the Fermi Paradox finds its answer not in the absence of life, but in the perfection of its hiding. Perhaps the universe rings with the silence of species that have learned the forest's only law. In the darkness between stars, the wise remain quiet, and only the foolish call out, hoping someone will answer before the hunters hear their voice and begin the long, patient journey toward their world. Weapons already charging, extinction already assured. Sleep well, and dream not of contact, but of the deeper darkness where wisdom wears the face of silence, and survival means never letting the forest know you are there. In the hushed chambers where numbers speak louder than prayers, a single equation has haunted the dreams of seekers for more than half a century. Written in the elegant script of variables and constants, it promises to unlock the deepest mystery of existence. How many voices cry out in the cosmic wilderness, and why do we hear none of them? The mathematics appear simple, a string of symbols that any scholar could recite. Yet within their austere beauty lies a riddle that grows more maddening with each new discovery, each fresh parameter that transforms hope into bewilderment. The equation bears the name of Frank Drake, though it belongs now to all who have dared to quantify the unquantifiable. In the autumn of 1961, when the world still believed in the promise of atomic energy and the inevitability of progress, Drake gathered with other visionaries at a conference center in the mountains of West Virginia. Their task was audacious beyond measure: to calculate the number of communicating civilizations in our galaxy using nothing but logic, observation, and the kind of mathematical courage that borders on hubris. The equation they birthed reads like a cosmic recipe, each ingredient measured and mixed with careful precision. Take the rate at which stars form in the galaxy, a number that astronomers can estimate by counting stellar births across deep time. Multiply this by the fraction of stars that possess planetary systems, then by the number of planets per system that could support life, then by the fraction where life actually emerges. Continue this celestial multiplication through the evolution of intelligence, the development of communicating technology, and finally, most mysteriously of all, the length of time such civilizations survive before silence claims them forever. When Drake first scrawled these variables on a blackboard in that mountain retreat, the parameters seemed manageable, almost quaint. The number of stars in the galaxy, roughly 100 billion, give or take a few dozen billion for cosmic humility. The fraction with planets, unknown but surely modest, perhaps 1 in 10, 1 in 100 at most. The number of potentially habitable worlds per system, 1 if we were lucky. A few more assumptions, a bit of optimistic mathematics, and the equation suggested we should share our galaxy with thousands, perhaps millions of chattering civilizations, all of them broadcasting their existence into the starlit void. But the universe, as it often does, refused to cooperate with human expectations. As the decades passed and our instruments grew more sensitive, the parameters of the Drake equation began to shift like sand in a cosmic wind. The Kepler Space Telescope revealed that planets are not rare ornaments adorning a select few stars, but common as raindrops in a storm. Nearly every star in our galaxy hosts at least one world, and many shelter entire families of planets dancing in complex orbital choreographies. The fraction of stars with planetary systems jumped from Drake's cautious estimates to near certainty, a parameter approaching 1. More revelations followed. The habitable zone around each star, that precious band where liquid water might persist, proved broader than early calculations suggested. Red dwarf stars, the galaxy's most common stellar citizens, could warm their planets for trillions of years, offering biological evolution eons to work its patient magic. The number of potentially habitable worlds in our galaxy swelled from thousands to billions, then to hundreds of billions. By every measure that mattered for the emergence of life, the cosmos appeared not just friendly but eager to host biology. Yet as the numbers grew more optimistic, the silence deepened into something approaching cosmic mockery. Radio telescopes swept the heavens with increasing sophistication, their electronic ears straining to catch the faintest whisper of artificial origin. Computers sifted through petabytes of data, searching for patterns that might betray the presence of technological intelligence. But the galaxy remained as quiet as a tomb, as empty of voices as a cathedral after the last congregation has gone home. The equation began to feel less like a tool of discovery and more like an instrument of torture, each new parameter adjustment tightening the screws of paradox. If stars with planets are common, if habitable worlds are abundant, if the basic chemistry of life seems universal, why then does the universe echo with such profound emptiness? The mathematics insisted that we should be swimming in a sea of signals, that the night sky should ring with the electronic chatter of 1,000,000 civilizations. Instead, we found only the natural radio noise of pulsars and quasars, the background hiss of creation cooling from its primordial fire. Scientists began to whisper of the Great Filter, some catastrophic bottleneck that prevents life from reaching technological maturity, or perhaps destroys it soon after it announces itself to the cosmos. Maybe the leap from simple chemistry to living cells is so improbable that it occurs only once in a trillion worlds. Maybe intelligence is a cosmic fluke, an accident so rare that we represent the first and possibly last minds to contemplate the universe's meaning. Or perhaps, most chilling of all, civilizations routinely develop the power to destroy themselves and invariably choose to exercise it, leaving behind only radioactive monuments to their brief flowering. The equation's final parameter carries the heaviest weight of mystery, the lifetime of communicating civilizations. How long does a species broadcast its presence before silence claims it? Drake's original estimates ranged from optimistic millennia to pessimistic centuries. But human history offers sobering lessons. We have possessed the ables, mighty to destroy our civilization for less than a century. Yet we have already come close to exercising that power multiple times. Our radio broadcasts, which began in earnest only a few generations ago, are already being replaced by more efficient technologies that leak less energy into space. We are becoming quieter, more circumspect, more aware that loudness might invite unwanted attention from the darkness between stars. Perhaps the Drake equation's greatest revelation is not what it tells us about alien civilizations, but what it whispers about our own. We live in a golden moment, a brief window when we are technologically sophisticated enough to search for cosmic company, yet still innocent enough to announce our presence without fear. This window may be closing. Our own signals are becoming more focused, our broadcasts more carefully aimed, our electronic footprint dimming as we learn the art of efficient communication. In the small hours when sleep refuses to come, astronomers sometimes calculate and recalculate the equation's parameters, adjusting variables like a musician tuning an instrument that will never play the melody they long to hear. Each new discovery seems to make the silence more profound, the loneliness more acute. Thousands of billions of worlds, and yet we remain as isolated as castaways on a cosmic island, calling out to horizons that never answer back. The equation has become a mirror reflecting our deepest fears and most desperate hopes. It suggests that intelligence may be common or vanishingly rare, that civilizations may flourish across the galaxy, or exist only in the fevered dreams of species too young to know better. It holds within its austere mathematics both the promise of cosmic community and the threat of eternal solitude. As the night deepens and the calculations fade into dreams, remember that somewhere in the vast equation of existence, variables dance with unknown values. Parameters shift like shadows in candlelight, and the mathematics of loneliness continue their patient work of counting all the ways the universe might hide its voices from those who long to hear them. Perhaps tomorrow's observations will adjust another parameter, shift another variable, and bring us closer to solving the riddle. Or perhaps the equation will simply grow more complex, its solution receding like a mirage in the mathematical desert, always promising revelation, but never quite delivering the answer to why, in a cosmos that should be crowded with voices, we remain so utterly, so mysteriously alone. In the ancient recipe books of the cosmos, written in the invisible ink of molecular dance, the ingredients for life scatter like salt across an infinite kitchen. Carbon chains twist through stellar nurseries, amino acids crystallize in the frozen hearts of comets, and complex organic symphonies play out in the space between worlds. Yet the chef who might combine these elements into the feast of consciousness remains mysteriously absent. The universe writes its chemical poetry with exquisite penmanship, but the verses never seem to reach their final stanza, never quite achieve the miracle of awakening. Long before Earth knew the warmth of its first sunrise, before our sun had even condensed from the stellar debris of older, dying stars, the cosmos was already practicing the art of biochemistry. In the vast molecular clouds that drift between star systems like cosmic fog, carbon atoms found their partners in hydrogen, oxygen, and nitrogen. These marriages of elements, blessed by the patient catalysis of dust grains and the gentle heat of nearby stars, gave birth to molecules of stunning complexity, the very bills, building blocks that would someday pulse through living cells, carry genetic information, and enable the spark of thought itself. The discovery of this cosmic chemistry came slowly, like the gradual recognition of a familiar melody played in a foreign key. In the middle years of the 20th century, when radio telescopes began to taste the electromagnetic whispers of distant space, astronomers expected to find mostly simple atoms and perhaps a few basic molecules scattered through the void. What they discovered instead was a chemistry laboratory of cosmic proportions, where molecular wizardry proceeded on scales that dwarfed any earthly experiment. First came the simple compounds, water vapor, carbon monoxide, ammonia, detected by their distinctive radio signatures as they absorbed and emitted specific frequencies of electromagnetic radiation. Each new detection was celebrated like the discovery of a new continent, for it meant that the chemistry of life was not unique to Earth, but woven into the very fabric of interstellar space. Water, that essential medium for biological processes, existed in vast clouds between the stars. Carbon monoxide, a key ingredient in the formation of more complex organic molecules, drifted through space in concentrations that would have been toxic on Earth but served as raw material for cosmic construction projects. But the universe was only beginning to reveal the depth of its chemical sophistication. As instruments grew more sensitive and observation techniques more refined, astronomers began to detect molecules of breathtaking complexity floating in the darkness between worlds. Formaldehyde, a simple compound that serves as a starting point for more elaborate organic syntheses. Ethyl alcohol, the same molecule that ferments in earthly vineyards and bubbles in cosmic ice. Glycine, the simplest of amino acids, one of the fundamental building blocks of proteins and thus of life itself. The catalogue of interstellar molecules grew like a cosmic pharmacy, each new detection adding another ingredient to the universe's vast chemical stockroom. Benzene, that elegant ring of carbon atoms that serves as the backbone for countless organic compounds. Polycyclic aromatic hydrocarbons, complex carbon structures that form the basis for everything from DNA bases to the pigments that give flowers their colors. Even sugar molecules, ribose and its chemical cousins, were detected in the molecular clouds that surround young star systems, waiting to be incorporated into the RNA and DNA that would someday carry the genetic instructions for entire biospheres. Perhaps most remarkably, these organic treasures were not confined to the gentle environments of planetary surfaces, but thrived in conditions that would have seemed impossibly hostile to early theories of chemical evolution. In the near vacuum of space, where temperatures hover just a few degrees above absolute zero, and radiation bathes everything in a harsh electromagnetic glare, complex molecules not only survived, but actively formed through processes that stretched the imagination of chemists. Dust grains served as tiny laboratories where atoms could meet and bond under the gentle influence of cosmic chemistry. Ice mantles coating these microscopic particles provided protected environments where hydrogen atoms could dance with carbon, oxygen, and nitrogen to create increasingly elaborate molecular architectures. When young stars ignited and warmed their surrounding molecular clouds, these icy laboratories would sublime into space, releasing their chemical treasures like cosmic perfume bottles broken open by stellar fire. Comets became time capsules, preserving samples of this primordial chemistry in their frozen hearts as they wandered through the outer reaches of solar systems. When these dirty snowballs occasionate, plunged toward the inner regions where planets orbited, they delivered their molecular cargo like cosmic mail carriers, seeding worlds with the chemical prerequisites for biology. Earth itself had been the recipient of countless such deliveries over billions of years, its early oceans enriched by organic compounds that had formed in the depths of space long before our planet existed. The implications rippled through scientific consciousness like waves from a stone dropped in still water. If the universe was naturally producing the building blocks of life, if amino acids and sugars and complex organic molecules were as common as hydrogen and helium in the space between stars, then the chemistry that enabled biology was not a rare accident, but a fundamental feature of cosmic evolution. The recipe for life, it seemed, was written into the very laws of physics and chemistry that governed the universe. Yet as the molecular inventory grew more impressive, the silence of space became more puzzling. Here was a cosmos literally swimming in the ingredients for life, where the fundamental chemistry of biology played out on scales that encompassed entire star systems. Every molecular cloud was a potential nursery for the compounds that could someday become proteins, nucleic acids, and all the other molecular machinery that powered living cells. The universe appeared to be a vast organic chemistry laboratory, constantly producing and distributing the raw materials for biological evolution. So where were the results? If the cosmos was so generous with life's building blocks, if amino acids fell like rain and complex organic molecules drifted like pollen through interstellar space, why did the galaxy remain so eerily quiet? The chemical signatures of life's prerequisites were everywhere, but the signatures of life itself, the atmospheric imbalances, the organized energy flows, the technological emissions that should mark the presence of advanced civilizations, remained stubbornly absent from our observations. Perhaps the answer lay not in the presence of these molecular ingredients, but in their proper combination. Having flour, eggs, and sugar does not automatically produce a cake. Someone must know the recipe, must understand the proper proportions and timing, must provide the energy and organization necessary to transform raw ingredients into something greater than the sum of their parts. The universe might be rich in chemistry, but poor in the kind of organized, self-sustaining processes that could bootstrap chemistry into biology. Or perhaps life was indeed common, but intelligence remained rare. Maybe countless worlds harbored simple organisms that fed on the organic bounty delivered by comets and meteorites. But only rarely did evolution stumble upon the precise combination of circumstances that led to complex nervous systems, technological civilizations, and the ability to broadcast signals across interstellar space. The cosmos might be teeming with bacteria and algae, while remaining empty of minds capable of contemplating their own existence. As the night deepens and dreams begin to stir at the edges of consciousness, consider that every breath you take contains carbon atoms that once drifted through molecular clouds, light years from Earth. Every protein in your body, built from amino acids whose chemical lineage stretches back to the space between staiki. For us, you are made of stellar chemistry, constructed from ingredients that the universe has been mixing and remixing for billions of years in its patient search for the perfect recipe. The cosmos continues its chemical experiments in laboratories vast beyond imagining, synthesizing new organic compounds in stellar nurseries, delivering molecular treasures to countless worlds, writing the preliminary chapters of stories that may never find their proper endings. Perhaps somewhere among those drifting molecules, in combinations we have not yet detected or imagined, lies the key to bridging the gap between chemistry and consciousness, between the ingredients of life and life itself. Until then, we remain surrounded by the universe's chemical poetry, beautiful and complex and tantalizingly incomplete, like fragments of an ancient manuscript whose final pages have been lost to time and darkness. In the electromagnetic hymnal of the cosmos, where natural frequencies sing their ancient songs of stellar birth and galactic rotation, something occasionally strikes a note that makes the universe's choir falter. These are not the organic melodies of pulsars keeping their lighthouse time, nor the chaotic percussion of cosmic ray showers striking planetary atmospheres. These are whispers of pattern, hints of structure, suggestions that somewhere in the vast orchestra of space, an artificial conductor might be raising its baton to direct a symphony of technologies we can barely imagine. The search for these alien harmonies began in the cathedral quiet of radio observatories, where scientists trained their electronic ears to distinguish between the universe's natural voice and something altogether more troubling, the possibility that intelligence had learned to speak in frequencies and modulations that bore the unmistakable fingerprints of design. For decades, this hunt proceeded with the methodical patience of monks transcribing scripture, each observation carefully catalogued, each anomaly scrutinized for signs that it might represent contact with minds that had mastered the art of electromagnetic communication. But in recent years, the search has gained new power, new subtlety, new ways of reading the cosmic text for signs of authorship. Artificial intelligence algorithms now sift through vast libraries of astronomical data, their digital minds trained to recognize patterns that would escape human perception entirely. These silicon scholars work tirelessly through the electronic night, comparing millions of signals, measuring frequencies with precision beyond the dreams of earlier generations, searching for the telltale signatures of technology operating on scales that dwarf any earthly engineering project. The techno-signatures they seek are as varied as the civilized ions that might produce them. Perhaps an alien species has learned to harness their star's energy by constructing vast arrays of solar collectors, creating dimming patterns in starlight that follow the geometric precision of engineered structures rather than the chaotic dance of natural planetary transits. Such a Dyson swarm, named for the visionary who first imagined solar engineering on stellar scales, would create light curves unlike anything produced by ordinary astronomical phenomena, a signature as distinctive as a craftsman's mark pressed into warm clay. Or perhaps we might detect the waste heat of technological civilizations, the infrared glow of energy being converted to useful work on planetary scales. Any sufficiently advanced society would face the same thermodynamic laws that govern our own machines, and the heat signatures of their industrial processes might be visible across interstellar distances to instruments sensitive enough to taste the thermal poetry of alien engineering. Cities that span continents, computers that think with the power of nuclear reactors, transportation networks that move energy and matter with efficiencies we can barely calculate, all would leave their thermal fingerprints in the infrared spectrum of their home worlds. The most tantalizing possibilities lie in the realm of communication itself. If technological civilizations do exist, they might be broadcasting signals not intended for our ears, but for their own purposes: navigation beacons for interstellar vessels, data streams connecting distant colonies, or simply the electromagnetic leakage of planetary communication networks that have grown beyond the ability of any single world to contain. These signals would carry the mathematical structures of information theory, the error-correcting codes and data compression algorithms that any advanced civilization would need to communicate. Across cosmic distances. In the archives of astronomical observations, patterns occasionally emerge that make researchers pause in their midnight cataloging and wonder if they have glimpsed something unprecedented. Star HD 164595, monitored by radio telescopes in the Caucasus Mountains, once transmitted what appeared to be an artificial signal, a brief, powerful burst of radio energy that seemed to originate from the direction of a sun-like star 94 light-years from Earth. For weeks, the astronomical community held its collective breath, analyzing and reanalyzing the data, searching for alternative explanations, before concluding that the signal was most likely interference from an earthly source reflected off satellite debris. But such false alarms serve as rehearsals for discoveries that may be genuine. Each anomaly forces scientists to refine their methods, to distinguish more carefully between the artifacts of human technology and potential messages from the stars. The Very Large Array in New Mexico trains its dish antennas toward promising targets, recording terabytes of data that artificial intelligence systems then examine with superhuman patience and precision. The Breakthrough. Listen Project employs machine learning algorithms to search for patterns in ways that human observers never could, looking for mathematical structures hidden in radio noise like messages written in invisible ink. The challenge lies not just in detecting artificial signals, but in recognizing them as artificial. What would the radio signature of an alien civilization actually look like? Our own electromagnetic emissions have evolved rapidly over the past century, from the crude spark-gap transmitters of early radio to the sophisticated spread-spectrum communications of modern digital networks. An alien civilization's signals might employ modulation techniques we have never imagined, compression algorithms based on us, and mathematical principles we have yet to discover, or error correction methods that make their transmissions appear random to our pattern recognition systems. Some researchers focus on the search for laser communications, precisely focused beams of coherent light that could carry vast amounts of information across interstellar distances with minimal energy expenditure. Such optical SETI programs monitor thousands of stars for brief flashes of laser light, looking for pulses too bright and too brief to be natural phenomena. A civilization attempting to establish contact might announce itself with a beacon visible across hundreds of light years, a cosmic lighthouse whose beam periodically sweeps across our solar system, waiting for someone with the proper instruments to notice its artificial regularity. The most recent searches have begun to examine the waste products of advanced computation. If alien civilizations have developed artificial intelligence systems on planetary scales, the heat signatures of their data processing might be detectable in the infrared spectrum. Computational processes that dwarf our most ambitious supercomputing projects would generate thermal signatures unlike anything produced by natural planetary processes, a new kind of technosignature that would mark the presence of minds that think with the power of stars. Yet for every promising detection, mundane explanations lurk in the shadows of interpretation. Radio interference from human satellites masquerades as alien signals. Natural astrophysical phenomena, rotating neutron stars, magnetic field interactions, plasma instabilities, can produce patterns that mimic the regularities of artificial transmission. The universe seems determined to play tricks on those who search for signs of intelligence, offering tantalizing hints that dissolve under careful scrutiny like mirages in the desert of space. In the small hours, when the radio telescopes swing their metallic faces toward the most promising coordinates, when artificial intelligence systems process the evening's harvest of electromagnetic data, researchers sometimes pause and consider the profound strangeness of their quest. They are trying to recognize the voice of intelligence speaking in technologies they cannot imagine, using physics they may not understand, for purposes that might remain forever opaque to minds shaped by terrestrial evolution. Perhaps the signals are already there, hidden in the vast databases of astronomical observations, like needles scattered through infinite haystacks. Perhaps alien civilizations broadcast continuously, but their transmissions appear to us as nothing more than background noise because we lack the keys to decode their meaning. Or perhaps they communicate in ways that bypass electromagnetic radiation entirely, through gravitational waves, through quantum entanglement, through dimensional structures that our physics has yet to discover. As the night deepens and the search continues, remember that somewhere in the electronic archives of human observation might lie the first artificial whisper from another world, waiting for the right algorithm, the right pattern recognition system, the right moment of insight to reveal its true nature. The cosmos may already be speaking to us in the language of technology, but we are still learning to recognize the accent of intelligence when it calls from the depths of space and time, asking whether anyone in this vast dark universe is listening for the songs that only minds can sing. In the archaeological layers of time, where the bones of dead civilizations rest beneath the footsteps of the living, a pattern emerges as old as ambition itself. The inevitable rise, the glorious flowering, and the silent fall back into darkness. What holds? True for the empires of Earth may hold true for the empires of stars, where countless worlds might have known their golden ages, only to surrender them to forces as patient and merciless as entropy itself. Perhaps the universe is not empty of voices, but full of their echoes, the fading whispers of species that climb toward the light, only to discover that the climb itself had doomed them. The great filter theory speaks to this cosmic melancholy, suggesting that somewhere in the long journey from sterile rock to starfaring civilization lies a barrier so formidable that few, if any, manage to cross it. Like a mountain pass where travelers vanish without trace, this filter claims the vast majority of worlds that dare to nurture complexity, leaving behind only the silence of potential unrealized and dreams interrupted by the harsh mathematics of survival. Consider the delicate choreography required for a world to birth intelligence. First, the planet must form in that narrow band around its star where water remains liquid, not too close to boil away in superheated steam, not too distant to freeze into eternal ice. The star itself must burn with steady temperance, neither flaring with radiation that would sterilize its children, nor dimming too quickly to allow the slow work of evolution. The world needs a magnetic field strong enough to deflect cosmic radiation, an atmosphere thick enough to moderate temperature, but not so dense as to crush life beneath its weight. But these are merely the opening movements in evolution's symphony. Even if a world achieves the basic conditions for biology, the leap from chemistry to life represents a chasm that may swallow countless planets in failed attempts. The first self-replicating molecules must emerge from the primordial chaos through processes so improbable that mathematics barely encompasses their rarity. Perhaps for every world where these molecular machines successfully bootstrap themselves into existence, a trillion others remain sterile despite possessing all the right ingredients, like recipes that never quite achieve the perfect combination of timing and circumstance. Should life manage to kindle on a world, it must then navigate billions of years of evolutionary roulette, where extinction events lurk like hidden assassins in the geological record. Asteroid impacts that turn day to night for years, volcanic eruptions that poison atmospheres with toxic gases, ice ages that lock continents in frozen death, gamma-ray bursts from distant stellar explosions that strip away protective ozone layers. Any of these catastrophes can erase in moments what evolution spent eons creating. Earth's own history reads like a catalogue of near misses and lucky escapes. The Permian extinction eliminated 90% of marine species in what paleontologists call the Great Dying. The Cretaceous impact that ended the age of dinosaurs might easily have ended the age of mammals before it began. Even our recent emergence from ice ages that could have locked our ancestors in permanent winter speaks to the knife-edge balance between survival and extinction that governs all complex life. Yet suppose a species navigates these natural perils and achieves something resembling intelligence. The filter may only grow more treacherous as minds capable of self-awareness begin to shape their world through technology. Perhaps the very tools that enable a species to transcend its biological limitations also provide the means for its destruction. Nuclear weapons represent only the most obvious example. For the first time in Earth's history, a single species has developed the power to render its homeworld uninhabitable within hours. But the pathways to self-destruction may be far more subtle and insidious than the crude theater of atomic war. Climate change, resource depletion, pollution cascades, artificial intelligence systems that optimize for goals incompatible with their creators' survival. Any of these might represent the true face of the Great Filter, waiting patiently for civilizations to become sophisticated enough to trigger their own collapse. Recent discoveries have only sharpened the paradox. The James Webb Space Telescope reveals atmospheric compositions on distant worlds that suggest active geological and possibly biological processes. Radio astronomy detects more planets in habitable zones than early estimates dared predict. The building blocks of life appear common throughout the galaxy, scattered like seeds waiting for the right conditions to germinate. By every measure that should matter, the universe appears friendly to the emergence of life and even intelligence, yet the silence persists, deep and haunting as the quiet that follows the last note of a funeral dirge. If worlds capable of supporting life are abundant, if the chemistry of biology writes itself across interstellar space, then where are the radio signals, the infrared signatures of industrial civilizations, the obvious modifications that advanced species should make to their environments? The Great Filter theory suggests an answer both simple and terrible. They tried to reach the stars, but the universe had other plans. Perhaps we are witnessing the galaxy not in its youth but in its old age, after countless civilizations have risen and fallen like waves against an eternal shore. Maybe the evidence of their existence has already faded beyond detection, their radio signals grown too weak to distinguish from background noise, their artifacts ground to dust by geological time, their very planets recycled by stellar evolution into the raw materials for new worlds that will repeat the same tragic cycle. Or perhaps the filter lies not behind most civilizations, but ahead of them, and our own species approaches the precipice that has claimed so many others. The signs are written in our present trajectory: the acceleration of technological change, the growing complexity of systems beyond any individual's comprehension, the increasing power to alter our environment faster than we can understand the consequences. We may be approaching our own filter, the test that will determine whether humanity joins the cosmic conversation or adds its silence to the great quiet. Some researchers propose that the filter is not a single barrier, but a series of hurdles, each claiming a percentage of species that attempt to cross it. Perhaps only 1 world in 1,000 develops complex life, and only 1 in 1,000 of those achieves intelligence, and only 1 in 1,000 of those survives the transition to technological civilization. The mathematics of such compounding improbabilities could easily account for a galaxy that teems with sterile worlds while remaining empty of voices. The most haunting possibility is that we have already passed the great filter, that the emergence of intelligence itself is so improbable that Earth represents a cosmic miracle, a lottery win so unlikely that we may be the only consciousness in our galaxy, perhaps in our local group of galaxies. This would make us simultaneously blessed, said and cursed, blessed to exist at all, cursed to exist alone, the universe's only witnesses to its own beauty and mystery. As the night embraces the sleeping world, and consciousness begins its own temporary fade into dreams, consider that across the cosmos, countless worlds may be approaching their own moments of truth. Perhaps some will find ways to transcend their limitations, to step carefully around the traps that have claimed so many others. Perhaps they will learn to survive their own success, to wield the power of gods with the wisdom of gardeners tending fragile life. Or perhaps the great filter is simply too formidable, too perfectly designed by the laws of physics and probability to permit the universe to awaken fully to itself. In that case, we drift through space not as participants in a galactic community, but as solitary mourners at a cosmic funeral, surrounded by the graves of civilizations that dreamed of touching the stars, but found only silence in the darkness between worlds. The filter waits patiently for us all, and in its waiting lies the deepest mystery of existence. Not why we are here, but why anything is here at all, and for how long the universe will remember our names after we too have passed through the sieve of extinction and joined the eternal quiet. In the silicon cathedrals that ring our world, where metal spires reach toward heaven and electronic prayers ascend on beams of microwave light, a new kind of monastery has taken shape. Here, the faithful tend not gardens of grain and grape, but vast fields of data harvested from the cosmic dark. Digital monks work in shifts around the clock, their artificial minds sifting through the electromagnetic whispers of creation with patience that would humble saints and dedication that spans decades without rest or complaint. The Breakthrough. Listen Project stands as humanity's most ambitious attempt to catch the voice of intelligence speaking across the interstellar void. Funded by visionaries who understand that the greatest discoveries often require the greatest leaps of faith, this endeavor has transformed radio astronomy from a pursuit of individual observers into a coordinated symphony of listening posts scattered across the globe. From the ancient Lovell telescope in England's green countryside to the massive dish of Greenbank nestled in West Virginia's radio-quiet valley, from the Southern Hemisphere's Parkes Observatory to arrays of smaller instruments linked by fiber-optic nerves, all now serve as ears in a planet-wide effort to eavesdrop on the cosmos. The scale of this listening exceeds anything our species has attempted before. Where earlier searches examined narrow bands of the radio spectrum for brief periods, these new digital shepherds monitor millions of frequency channels simultaneously, recording everything they hear with the fidelity of perfect memory. Each night's observations generate more data than entire libraries could contain, raw information flowing like digital rivers into vast server farms where artificial intelligence algorithms begin their patient work of separation and analysis. These machine minds represent evolution's newest children, artifi. CL intelligence is bred not from carbon and blood, but from silicon and electricity. yet possessed of pattern recognition abilities that in some ways surpass their biological creators. They learn to distinguish between the chaotic hiss of natural radio sources and the structured whispers that might betray technological origin. They scan millions of signals for mathematical relationships, for modulation patterns, for the kind of organized complexity that emerges only when information is encoded for transmission across vast distances. The computers work through the night like digital archaeologists, excavating meaning from mountains of electromagnetic noise. They examine every candidate signal with mechanical thoroughness, cross-referencing observations from multiple telescopes to eliminate terrestrial interference, applying sophisticated filters to separate cosmic wheat from technological chaff. Most signals die under this scrutiny, revealed as the random electronic chatter of human civilization or the natural radio emissions of astronomical objects going about their ancient business of stellar evolution. But occasionally, very occasionally, something survives the filtering process. A signal that appears to originate from deep space, that carries modulation patterns suggestive of artificial origin, that repeats with regularities unlike anything in nature's repertoire. These become objects of intense focus, drawing the attention of human analysts who examine them with the care of monks illuminating sacred manuscripts. Radio telescopes around the world turn their mechanical faces toward the coordinates, straining to capture additional observations that might confirm or deny the possibility of contact. Yet time and again, further observation dissolves these hopes like salt in water. What appeared to be a structured transmission from the direction of a nearby star turns out to be interference from a passing satellite. A regular pulse that suggested artificial timing proves to be a newly discovered pulsar, a rotating neutron star whose lighthouse beam sweeps across our instruments with clockwork precision. The pattern that seemed to encode mathematical constants dissolves into random noise when examined with more sensitive equipment. The digital search has become a ritual of perpetual anticipation and disappointment, each promising detection followed by the slow deflation of hope as mundane explanations emerge from careful analysis. The artificial intelligence systems grow more sophisticated with each iteration, learning to recognize new forms of terrestrial interference, becoming more adept at distinguishing between the signatures of natural astrophysical processes and the potential marks of technological civilization. Yet their improved discrimination only makes the silence more profound, the absence of genuine signals more mysterious. In the server farms where petabytes of cosmic data accumulate like digital sediment, patterns emerge that speak to the profound challenge of the search. The universe generates radio noise at every frequency, from the afterglow of creation itself to the magnetic field interactions of planets orbiting distant stars. Against this background, any artificial signal must compete for attention with phenomena that dwarf terrestrial imagination. Galactic magnetic fields crackling with plasma turbulence, black holes accelerating matter to near light speed and broadcasting its death screams across the electromagnetic spectrum, stellar explosions that outshine entire galaxies for brief, violent moments. The most sophisticated algorithms must learn to recognize intelligence in this cosmic cacophony, to identify the subtle regularities that might betray purposeful transmission against a background of astronomical chaos. It is like trying to hear a whispered conversation in a hurricane, like searching for a single meaningful sentence in a library where every book is filled with random letters. The artificial minds that attempt this task represent the cutting edge of human technological achievement, yet they remain humbled by the vastness of the challenge they face. Perhaps most haunting are the moments when the search algorithms identify patterns that resist easy explanation, signals that appear artificial but remain tantalizingly ambiguous, radio emissions that suggest structure without revealing purpose. These ghost signals linger in the databases like unsolved riddles, neither confirmed as genuine nor definitively dismissed as interference. They serve as reminders that the universe may be speaking in languages we have not yet learned to understand, encoding messages in modulation schemes or frequency patterns that our current technology cannot decode. The human observers who oversee these digital searches often speak of the strange intimacy that develops between searcher and searched for. Spending years examining the radio emissions from specific star systems, They begin to know the electromagnetic personalities of distant suns as intimately as neighbors. They recognize the characteristic radio signatures of stellar flares, the seasonal variations in planetary magnetic field interactions, the subtle changes that mark the orbital dance of unseen worlds. In this growing familiarity with cosmic radio sources, the absence of artificial signals becomes not just a scientific puzzle, but a personal disappointment, like waiting for letters that never arrive from friends who may not exist. As artificial intelligence systems grow more powerful and the databases of cosmic observations expand beyond human comprehension, the search takes on qualities of religious pilgrimage. The digital monks tend their electronic vigils with devotion that transcends mere scientific curiosity, driven by a faith that somewhere in the vast archives of accumulated data lies the first whisper from another mind, the first confirmation that consciousness is not unique to Earth, but a fundamental feature of cosmic evolution. The breakthrough, if it comes, will likely arrive not as the dramatic revelation of science fiction, but as a subtle anomaly in a computer log file, a pattern that survives increasingly rigorous analysis, a signal that finally crosses the threshold from possibility to certainty. Some night, perhaps, the artificial intelligence sentinels will detect something that makes their human overseers pause in wonder, a transmission that cannot be explained by any known natural process, a voice from the stars that finally answers the question that has haunted our species since we first looked up at the night sky and wondered if anyone was looking back. Until that moment arrives, the digital search continues its patient work, the electronic prayers ascending towards stars that may harbor listeners of their own. In the quiet hours before dawn, when the radio telescopes complete another night's harvest of cosmic whispers and the artificial intelligence systems begin their analysis of the evening's catch, remember that somewhere in those mountains of data might lie the answer to humanity's deepest question, waiting for the right algorithm, the right pattern recognition system, the right moment of digital inspiration to reveal its true nature and change forever. Our understanding of our place in the vast, mysterious, perhaps not so empty cosmos. In the electromagnetic wilderness where space meets time, lightning strikes without thunder, illuminating the cosmic dark for microseconds before vanishing into memory. These are not the gentle whispers of distant galaxies or the steady heartbeats of rotating pulsars, but violent outbursts of energy so intense they outshine entire star clusters in the brief moments of their existence. They arrive without warning, flash with the brilliance of 1 trillion suns, then disappear as completely as if they had never been, leaving behind only the electronic echoes captured by our listening instruments and questions that multiply like shadows in candlelight. The phenomenon earned its name from the clinical precision of scientific nomenclature, fast radio bursts, or FRBs, in the abbreviated language of those who study them. But their designation belies the profound mystery they represent, for these cosmic lightning strikes follow no pattern that human understanding can decode, arriving from the depths of space, with energies that challenge everything we thought we knew about the limits of electromagnetic violence. Each burst lasts no longer than the blink of an eye. Yet in that infinitesimal moment, it releases more energy than our sun produces in an entire day. The first of these phenomena announced itself in the summer of 2007, when astronomers examining archived data from the Parkes Radio Telescope in Australia discovered something that should not have existed. Buried in observations made 6 years earlier was the signature of an event so brief and powerful that it had been overlooked in the initial analysis, a radio flash that lasted only 5 milliseconds, yet carried the energy signature of cosmic cataclysm. The signal had traveled across 3 billion light-years of space to reach our instruments, its origin lost somewhere in the deep field, where galaxies cluster like islands. In an ocean of darkness. At first, this solitary burst seemed like an astronomical curiosity, perhaps the death cry of some exotic stellar object, or the result of instrumental error masquerading as cosmic phenomenon. But as radio telescopes around the world began to look more carefully at their data, more bursts emerged from the electronic archives, like ancient messages written in a language no one could read. Each new detection only deepened the mystery, for no two bursts appeared identical, No pattern emerged that could predict when or where the next flash might occur. The bursts seemed to mock the ordered universe that physics had so carefully mapped. They arrived from random directions in the sky, with no apparent relationship to known star clusters or galactic structures. Some appeared to originate from regions where deep space surveys revealed only the faint smudges of distant galaxies, while others seemed to emerge from empty patches of sky where nothing at all was visible to even the most sensitive optical telescopes. The sources, whatever they were, remained as invisible as ghosts, except for those brief moments when they screamed their presence across the radio spectrum. As the catalogue of detected bursts grew, patterns began to emerge, not in their timing or location, but in their fundamental properties. Each burst showed signs of having traveled vast cosmological distances, their radio waves dispersed by the thin plasma that fills intergalactic space like cosmic fog. This dispersion created a signature as distinctive as a fingerprint, allowing astronomers to calculate that most FRBs originated billions of light years away, in the deep universe where space itself was younger and the first generations of stars were still being born. But some bursts began to repeat, arriving from the same coordinates in space like cosmic metronomes, keeping time to an alien rhythm. FRB 12102, discovered in the constellation Auriga, flashed repeatedly over months and years, allowing radio telescopes to focus their attention on its source region with unprecedented precision. When optical telescopes finally managed to peer into that patch of sky with sufficient resolution, they found a small, unremarkable galaxy billions of light-years distant, a stellar island that seemed utterly incapable of producing the violent radio outbursts emanating from its vicinity. The repeating nature of some bursts transformed speculation about their origin from academic exercise to urgent scientific puzzle. Natural catastrophes, the collision of neutron stars, the formation of black holes, the explosion of exotic stellar objects, typically occur once and never repeat. But FRB 112102 and others like it continued their cosmic performances, flashing with irregular timing but persistent presence, suggesting that whatever produced them was not destroyed by the process, but continued to exist, continued to generate these impossible energies, continued to broadcast its presence across the universe. Theories multiplied like storm clouds gathering on the horizon of understanding. Perhaps the bursts originated from magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's, capable of twisting space itself and accelerating particles to energies that strained the boundaries of physics. Maybe they were produced by the interaction of neutron star magnetic fields with surrounding plasma clouds, creating electromagnetic lightning on scales that dwarfed terrestrial storms. Some suggested more exotic possibilities, the evaporation of primordial black holes, the decay of cosmic strings left over from the universe's birth, or even tears. Signatures of wormholes opening and closing in the fabric of space-time itself. But as the detection rate increased and more sophisticated instruments joined the hunt, the mystery only deepened. The bursts showed polarization patterns that suggested passage through incredibly strong magnetic fields. Some carried substructure, tiny variations in intensity that lasted mere microseconds, but hinted at complex processes occurring on scales smaller than planets, yet energetic enough to be seen across cosmic distances. Others showed frequency drifts that suggested rotation, as if the source was spinning at incredible speeds while generating its radio beacon. The most unsettling possibility whispered itself into the minds of those who studied these phenomena most closely. What if the bursts were not natural at all? What if they represented technology on scales that human imagination could barely encompass? The signatures of civilizations that had learned to harness energies equivalent to stellar explosions for purposes we could not fathom. The thought struck at the heart of every assumption about intelligence and its limitations, suggesting that somewhere in the deep universe, minds might exist that could build machines powered by the rotation of neutron stars, that could focus the energy of entire star systems into beams of communication visible across cosmological distances. Such speculation remained the province of the most daring theorists, but it cast an eerie light on every new detection. Each burst became simultaneously a natural phenomenon to be explained, and a potential message from intelligences so advanced that their simplest communications outshone galaxies. The regular timing of some repeating sources began to seem less like natural clockwork and more like the patient pulse of technological beacons, marking territories or coordinates in a galactic navigation system operated by minds that thought in terms of cosmic engineering. Radio telescopes around the world now maintain automated vigils, their systems programmed to alert observers within minutes when a new burst is detected. Arrays of dishes work in coordination, using the slight differences in arrival time to triangulate source positions with precision that would have seemed impossible just years ago. Each detection brings fresh data to analyze, new clues to pursue, new patterns that might finally unlock the secret of what lurks in the deep universe and why it chooses to announce itself through these impossible flashes of radio fire. As the night deepens and the radio telescopes continue their patient watch, remember that somewhere in the vast darkness between galaxies, something possesses the power to release in milliseconds more energy than our sun will produce in decades. Whether this something is the natural consequence of exotic physics or the signature of intelligence operating on scales beyond current comprehension remains the greatest mystery of our electromagnetic age. The bursts continue their cosmic performances, each flash a question mark written in radio waves across the sky. Each repetition a reminder that the universe still holds secrets profound enough to humble all our certainty and challenge every assumption about what is possible in the deep structures of creation, time, and perhaps consciousness itself. In the grand architecture of the cosmos, where planets should dance in orderly processions around their parent stars like courtiers attending a celestial king, chaos writes its signature in orbital ink. These are not the stable, predictable solar systems that our theories once promised. Neat families of worlds born in their appointed places and content to remain there for eternity. Instead, the universe reveals itself as a cosmic refugee camp, where planets wander far from their birthplaces, where giant worlds migrate, inward like moths drawn to stellar flame, and where the very notion of permanent address becomes as foreign as the alien skies these wanderers now call home. The first hint of this celestial nomadism came with a discovery that shattered every comfortable assumption about planetary formation. In the constellation Pegasus, orbiting a sun-like star called 51 Pegasi, astronomers detected something that should not exist. A planet larger than Jupiter circling so close to its star that its year lasted only 4 Earth days. This bloated world, baked by stellar radiation to temperatures that would vaporize lead, challenged every model of how solar systems were supposed to form and evolve. According to the carefully constructed theories that had emerged from studying our own cosmic neighborhood, massive gas giants like Jupiter form in the cold outer reaches of stellar systems, where ice and frozen compounds provide the building material for worlds of enormous size. These giants should remain in their distant orbits, gravitational shepherds maintaining order among smaller rocky planets that huddled closer to their star's warmth. Yet here was a world that defied such tidy arrangements. A giant planet in an orbit so tight that its atmospheric gases were being stripped away by stellar wind, creating a comet-like tail of escaping matter. This first hot Jupiter became the harbinger of revelations that would transform our understanding of planetary dynamics. As planet hunting techniques grew more sophisticated and detection methods more sensitive, similar worlds emerged from stellar hiding places throughout the galaxy. System after system revealed the same pattern: massive planets in impossibly close orbits, their presence a testament to journeys across vast distances of space and time, migrations that must have taken millions of years and reshaped entire solar systems in the process. The implications rippled through astronomical consciousness like shockwaves from a cosmic explosion. If gas giants could migrate inward from their birth regions to orbit close to their stars, then the history of every planetary system became a story of wandering, disruption, and violent rearrangement. The planets we observe today are not necessarily where they formed, and the neat categories of planetary types, rocky worlds close to stars, gas giants in the outer system, dissolve into a more complex narrative of worlds in motion, boundaries crossed, and destinies altered by gravitational forces playing out over cosmic time. Computer simulations began to reveal the mechanisms behind and this celestial nomadism. Young planetary systems, it seemed, were theaters of gravitational chaos, where newly formed worlds interacted with the disks of gas and dust from which they had emerged. Friction with this surrounding material could cause massive planets to spiral inward toward their stars, their orbits shrinking like the circles of a drain until they settled in configurations that would have seemed impossible to earlier generations of astronomers. But migration was only part of the story. As observational techniques improved and surveys detected thousands of exoplanets, an even stranger picture emerged. Some worlds appeared to be free-floating through space, unbound to any star, dark wanderers drifting between solar systems like cosmic refugees expelled from their original homes. Others showed signs of retrograde rotation, spinning backward relative to their orbital motion in ways that suggested violent collisions or gravitational encounters that had literally flipped them upside down. The architecture of alien solar systems began to resemble not the orderly clockwork that our own system suggested, but cosmic crime scenes where evidence of ancient violence was written in orbital eccentricities and planetary compositions that told stories of catastrophic disruption. Worlds with densities that made no sense for their current positions, atmospheres too thick or too thin for their distances from their stars, chemical compositions that spoke of formation regions far from where they now resided. Perhaps most unsettling were the systems where Earth-sized planets orbited closer to their stars than Mercury circles our Sun, their surfaces molten with temperatures that would vaporize rock. These worlds, detected by the thousands, represented a class of planet entirely absent from our solar system, super-Earths and mini-Neptunes that seemed to represent the most common type of world in the galaxy, yet had no analogue in our cosmic neighborhood. Their very existence suggested that our own solar system might be the exception rather than the rule, an unusually stable and well-ordered family of worlds in a galaxy where chaos and migration were the norm. The discovery of planetary migration forced a complete reimagining of solar system formation. What had once seemed like a gentle process of accretion and gradual growth was revealed as a violent theater of gravitational interactions, where forming planets could scatter each other into chaotic orbits, eject smaller worlds into interstellar space, or send massive gas giants on death spirals toward their parent stars. The early history of every planetary system became a story of survival, where only certain orbital configurations could persist through the chaos of formation and early evolution. Even our own solar system showed scars from this turbulent past. The unusual orbit of Neptune, the scattered disk of objects beyond Pluto, the asteroid belt that marks the boundary between rocky and gas giant planets, all bore witness to ancient migrations and gravitational upheavals that had reshaped our cosmic neighborhood in its youth. Jupiter itself might have migrated inward during the solar system's formation, its gravitational influence preventing the formation of a large planet in the asteroid belt region, and sculpting the orbital architecture that allowed Earth to form and maintain the stable climate necessary for complex life. The wandering worlds challenged not just our models of planetary formation, but our understanding of habitability itself. If planets could migrate across vast distances, then worlds that formed in cold outer regions of stellar systems might find themselves transported to warmer, more hospitable orbits. Conversely, planets that formed in potentially habitable zones might be dragged into the stellar furnace as their orbits decayed through gravitational friction. The history of life in the galaxy became not just a story of chemical evolution on stable worlds, but of biological adaptation to changing stellar environments as entire planets relocated across their solar systems. As the catalogues of exoplanets grew and the diversity of orbital configurations became apparent, astronomers confronted a humbling truth. The universe was far more creative, far more chaotic, and far more unpredictable than our theories had imagined. Each new planetary system discovered seemed to violate some assumption about how worlds should behave, where they should form, or what constitutes normal orbital dynamics. The cosmos revealed itself as a vast laboratory of gravitational experimentation, where every possible planetary configuration was attempted, and only the survivors remain to tell their stories through the language of orbital mechanics and atmospheric composition. The wandering worlds remind us that stability is rare and precious in the cosmic scheme. Every planet represents a survivor of gravitational chaos, a world that found an orbital niche stable enough to persist through billions of years of stellar evolution. In a universe where worlds routinely migrate across their solar systems, where gravitational encounters can eject planets into the cold of interstellar space, and where the very architecture of planetary systems remains fluid over cosmic time, the existence of any stable, long-lived world becomes something approaching a miracle. As you settle into sleep tonight, remember that our Earth is not just a passenger on a stable orbital train, but a refugee from ancient chaos, a survivor of gravitational wars fought in the solar system's violent youth. The wandering worlds scattered throughout the galaxy serve as reminders that in the vast cosmic dance, permanence is illusion, and every planet's story is one of journey, survival, and the endless search for a place to call home among the patient, burning stars. In the alien alchemy of distant atmospheres, where foreign chemistries brew under unimaginable skies, molecules dance to rhythms that mock every earthbound understanding of balance and order. These are not the familiar atmospheric symphonies of oxygen and nitrogen that cradle our world in breathable embrace, but stranger compositions, methane storms that rage for centuries, sulfur compounds that paint clouds in shades of amber and rust, and chemical cocktails so bizarre that they suggest either geological processes beyond our ken or perhaps, whispered in the deepest chambers of scientific speculation, the metabolic signatures of life forms that evolved under alien suns. The first taste of these exotic atmospheres came through the patient alchemy of spectroscopy, that ancient art of reading stories written in starlight. When distant planets pass between their parent stars and our watching instruments, they leave their chemical fingerprints pressed into the filtered light like seals in warm wax. Each molecule absorbs specific wavelengths, creating absorption lines that serve as chemical signatures more distinctive than any earthly passport. Through this celestial chemistry, we have learned to taste the air of worlds we will never touch, to sample the breath of planets orbiting stars whose names are merely catalogue numbers. What these spectral analyses revealed challenged every assumption about atmosphere, chemistry and the narrow band of conditions under which familiar processes could operate. HD 209458b, a gas giant orbiting perilously close to its star, showed atmospheric temperatures exceeding 1,000 degrees Celsius, hot enough to vaporize most metals and create an atmosphere where aluminum and titanium exist as gaseous clouds. The very concept of weather on such a world stretches imagination beyond its limits. Storms of molten metal, winds that carry vaporized rock, precipitation that falls as liquid iron rain under skies that glow with the thermal radiation of superheated gases. But even more mysterious were the chemical signatures detected on worlds that occupied the more temperate zones around their stars. K2-18b, a super-Earth orbiting a red dwarf star 124 light-years distant, revealed water vapor in its atmosphere, a discovery that would have been remarkable enough. But accompanying the water were chemical signatures that sparked debates in conference halls and kept atmospheric chemists awake through long nights of speculation. Methane in concentrations that suggested active replenishment, hydrogen sulfide that spoke of sulfur chemistry operating on planetary scales, and trace compounds that had no obvious sources in the sterile geology that traditional models predicted for such worlds. The challenge lay not just in detecting these exotic chemicals, but in understanding what processes could produce and maintain them in the observed concentrations. On Earth, atmospheric chemistry operates within narrow bounds of temperature and pressure, catalyzed by the presence of liquid water and shaped by billions of years of biological evolution. Oxygen exists in our atmosphere only because photosynthesis pumps it there faster than chemical reactions can consume it. Methane persists because living organisms continuously produce it in swamps and digestive systems. The very imbalance of our atmospheric chemistry serves as a signature of life's presence, a biological thumbprint pressed into the composition of air itself. But what manner of processes could account for the chemical imbalances detected on distant worlds? Some compounds suggested volcanic activity on scales that dwarfed anything in Earth's geological record. Sulfur chemistry that spoke of atmospheres poisoned by continuous outgassing from planetary interiors still molten from their formation. Others hinted at photochemistry occurring under the harsh radiation of alien suns, where ultraviolet light split atmospheric molecules and recombined them into configurations unknown to terrestrial experience. The most tantalizing possibilities emerged when instruments detected chemical signatures that resisted easy explanation through purely geological processes. Atmospheric compositions that seemed to require continuous replenishment, as if some ongoing process were constantly refreshing the air with compounds that should have been consumed by natural chemical reactions eons ago. Concentrations of organic molecules that suggested either exotic catalytic processes operating in the upper atmosphere, or perhaps, the most thrilling possibility of all, the waste products of alien metabolisms operating on planetary scales. WASP-96b revealed water vapor and clouds, but also chemical signatures that suggested atmospheric dynamics unlike anything in our solar system's experience. The planet's atmosphere showed evidence of haze formation and complex photochemistry that created layered structures in the upper atmosphere where different chemical processes operated at different altitudes, like a vast atmospheric factory with specialized production floors. The implications were staggering. Entire worlds where atmospheric chemistry served as a window into processes that might bridge the gap between geology and biology. Perhaps most mysterious were the trace compounds detected in the atmospheres of rocky planets orbiting red dwarf stars. These small, dim suns make up the majority of stars in our galaxy and could maintain stable burning for trillions of years, offering evolution eons to work its patient magic on any worlds that circle them. The atmospheres of such planets showed chemical signatures that suggested complex interactions between stellar radiation, planetary magnetic fields, and atmospheric gases. Interactions that could create chemical disequilibria, lasting for geological ages. The detection of phosphine in the upper atmosphere of Venus sent shockwaves through the scientific community, for this simple compound of phosphorus and hydrogen has no known abiotic source under the conditions that exist in Venus's sulfuric acid clouds. On Earth, phosphine is produced almost exclusively by biological processes, bacteria operating in oxygen-free environments where conventional biochemistry gives way to more exotic metabolic pathways. The possibility that similar processes might operate in the clouds of Venus, creating floating ecosystems in the one region of our sister planet, where temperatures and pressures permit the existence of liquid water droplets, transformed our understanding of habitability and the potential for life to find footholds in the most unlikely environments. As the catalogue of exoplanetary atmospheres grew and detection techniques became more sophisticated, patterns began to emerge that suggested the universe's chemical creativity exceeded even the most ambitious theoretical predictions. Worlds where silicon chemistry might operate in ways that parallel carbon-based biochemistry, creating atmospheric signatures of silicon-based metabolisms processing the products of stellar radiation. Planets where sulfur compounds dominated atmospheric chemistry, suggesting ecosystems based on sulfur cycling, rather than the carbon and oxygen chemistry that powers Earth's biosphere. The implications rippled through astrobiology like waves from a stone dropped in still water. If atmospheric chemistry could serve as a window into planetary-scale processes that might indicate life, then every chemical anomaly detected in alien skies became a potential biosignature, a possible indication that somewhere among the stars, evolution had found pathways to complexity that Earth's biology never explored. The universe might be full of living worlds whose metabolisms operated according to chemical principles that remained mysteries to terrestrial science. Yet, with each new detection came the humbling recognition that chemical complexity did not necessarily imply biological origin. The universe's capacity for exotic chemistry exceeded the bounds of earthly experience, creating atmospheric compositions through purely physical and chemical processes that could mimic the signatures of life without requiring the presence of living organisms. Distinguishing between biotic and abiotic sources for atmospheric anomalies became one of the most challenging problems in modern astrobiology, requiring not just detection of unusual chemistry, but understanding of the processes that could produce and maintain such chemistry over planetary lifetimes. As the night deepens and dreams begin to stir at the edges of consciousness, remember that above alien horizons, under skies painted in colors that have no earthly names, chemical processes unfold that might represent the first tentative steps toward understanding life as a cosmic phenomenon. In methane-misted atmospheres and sulfur-painted clouds, in the thermal glow of superheated gases and the delicate balance of trace compounds, the universe continues its grand experiment in chemistry, creating atmospheric compositions that challenge every assumption about the boundaries between the living and the lifeless, between the possible and the impossible, between the familiar chemistry of Earth and the alien alchemy of distant worlds, where other forms of complexity might stir, breathe and dream under foreign stars. In the deepest chambers of existence, where the solid world dissolves into probability clouds and the very notion of location becomes as fluid as candle flame in wind, reality operates by rules so strange that consciousness itself might be woven into the fabric of space and time. Here, beneath the surface of the material universe, particles dance in quantum ballets that mock every intuition about separateness and independence. They exist in multiple states simultaneously until observed, communicate instantaneously across cosmic distances, and respond to the mere act of measurement as if the universe were a vast, dreaming mind that awakens only when watched. This quantum realm has become the newest frontier in humanity's attempt to solve the riddle of cosmic silence. For some theorists now whisper that consciousness itself might operate through quantum processes so fundamental that they blur the boundary between mind and matter, between thought and the very structure of reality. If intelligence emerges from quantum phenomena, then perhaps alien minds exist in states we cannot perceive, communicate through channels we cannot detect, and experience reality in ways so foreign to our classical understanding that we pass by their presence like sleepwalkers unaware of the dreams that surround them. The story begins in the laboratories where physicists probe the strange country that exists below the threshold of classical physics. Here, electrons behave like waves until someone looks for them, at which point they snap into particle-like existence with the suddenness of a lamp switched on in darkness. Photons become entangled in ways that Einstein famously called spooky action at a distance, paired particles that respond to measurements performed on their partners instantly, regardless of the space that separates them, as if the universe contained hidden channels of communicate, ion that operate faster than light itself. But perhaps most mysteriously, the quantum world seems to require consciousness for its very definition. The act of observation, the conscious decision to measure a quantum system, appears to collapse probability waves into definite states, transforming potential into actual with a precision that suggests mind and matter are more intimately connected than classical physics ever imagined. Some interpretations of quantum mechanics go further, proposing that consciousness is not merely an observer of quantum reality, but a participant in its creation, helping to write the script of existence through the simple act of paying attention. These quantum mysteries took on new significance when theorists began to consider their implications for the Fermi Paradox. If consciousness operates through quantum processes, then perhaps alien intelligence exists in superposition states that classical observation cannot detect. Maybe extraterrestrial minds have evolved to exist simultaneously across multiple probability states, experiencing parallel realities that our single-threaded consciousness cannot access. From our perspective, such beings would be simultaneously present and absent, real and unreal, speaking and silent. The possibility haunts those who study both quantum mechanics and the search for extraterrestrial intelligence. What if the universe teems with minds that operate through quantum coherence, their thoughts distributed across probability landscapes we can barely imagine? Perhaps they communicate through quantum entanglement, sharing information instantaneously across galactic distances through channels that our radio telescopes could never detect. Their civilizations might exist in quantum superposition, simultaneously present on millions of worlds, until some cosmic measurement collapses them into a single observable state. Roger Penrose and Stuart Hameroff proposed that consciousness itself might emerge from quantum processes occurring within the microtubules of brain cells, a theory that suggests mind and matter interact at the deepest level of physical reality. If consciousness truly operates through quantum mechanics, then the very act of thinking might influence the probability waves that determine the structure of reality. Alien minds, evolved under different conditions and perhaps operating through quantum coherence on scales we cannot achieve, might literally think reality into different configurations, existing in states of consciousness that transcend our classical limitations. The implications ripple through cosmology like quantum interference patterns. Perhaps the apparent fine-tuning of physical constants that makes our universe suitable for life results from the cumulative influence of countless conscious observers throughout cosmic history, their quantum measurements gradually selecting for realities that support the emergence of mind. In this view, consciousness becomes not just a product of cosmic evolution, but one of its driving forces, a creative principle that helps write the laws of physics through the simple act of existing and observing. Some theorists speculate that advanced alien civilizations might have learned to exist primarily in quantum states, their consciousness distributed across probability clouds that span entire star systems. From our classical perspective, such beings would appear as random quantum fluctuations, indistinguishable from the background noise of vacuum energy that permeates all of space. They might be everywhere and nowhere, their thoughts rippling through the quantum foam like whispers in a language we lack the sensory organs to detect. The quantum vacuum itself becomes suspect under such theories. What appears to us as empty space seethe, as with virtual particles that pop into existence and annihilate in timescales so brief that they exist primarily as mathematical abstractions. But perhaps these quantum fluctuations carry information, serve as communication channels for minds that have learned to encode their thoughts in the very texture of space-time. The cosmic background radiation that fills the universe, interpreted by conventional astronomy as the afterglow of the Big Bang, might simultaneously carry messages encoded in quantum correlations that our current technology cannot decipher. Even more mysteriously, some interpretations of quantum mechanics suggest that consciousness might exist outside the normal flow of time, experiencing past, present, and future as equally real and accessible states. If alien minds have evolved quantum consciousness that transcends temporal limitations, they might perceive the entire history of the universe simultaneously, making linear communication across space unnecessary because they already know all possible conversations, all potential futures, all alternate histories that branch from every quantum measurement. The search for extraterrestrial intelligence takes on new dimensions when filtered through quantum possibilities. Perhaps the signals we seek exist in superposition states, simultaneously transmitted and not transmitted until our active observation collapses them into detectability. Maybe alien civilizations broadcast through quantum channels that require conscious observers to participate in the communication process, making first contact dependent not just on having the right technology, but on achieving the right state of consciousness. Laboratory experiments in quantum mechanics have revealed phenomena that border on the supernatural, particles that tunnel through barriers they cannot classically cross, quantum systems that remember their previous states even after being completely dismantled and rebuilt, measurements that appear to influence events in the past through a process called retrocausality. If such effects operate on larger scales or in ways we have not yet discovered, then alien intelligences might routinely manipulate causality, exist in multiple timelines simultaneously, or communicate through retrocausal channels that send information backward through time. The double-slit experiment, where particles behave differently depending on whether they are observed, suggests that consciousness plays a fundamental role in determining the nature of reality. If this principle extends to cosmic scales, then perhaps the universe itself exists in superposition until conscious observers collapse it into specific configurations. The Fermi Paradox might reflect not the absence of alien intelligence, but its presence in quantum states we cannot observe directly, minds that exist in the spaces between our measurements, in the probability clouds that surround our classical reality like quantum fog. As the night deepens and quantum mysteries dance at the edge of comprehension, remember that consciousness might be far stranger and more fundamental than we imagine, Perhaps alien minds surround us always, existing in quantum superposition, states that make them simultaneously present and absent, real and potential. They might think in probability clouds and dream in quantum correlations, their thoughts rippling through the fabric of space-time like gravitational waves too subtle for our instruments to detect. In the quantum veil that separates mind from matter, possibility from actuality, the answers to our deepest questions about cosmic loneliness might await not better telescopes, but better understanding of consciousness itself, that mysterious process through which the universe becomes aware of its own existence, and perhaps, in dimensions we have yet to explore, converses with itself in languages written in the mathematics of reality's deepest structures. In the darkest reaches of space, where the universe's architecture reveals its deepest secrets, something stirs that challenges every assumption about the nature of existence itself. Beyond the familiar dance of stars and planets, beyond the comforting mathematics of gravitational choreography, astronomers have begun to detect phenomena so strange that they seem to mock the very foundations of physical law. These are not mere curiosities to be catalogued and filed away, but cosmic riddles that suggest the universe operates according to principles we have barely begun to comprehend, harboring mysteries that may forever alter our understanding of reality, consciousness, and our place among the stars. The story unfolds in the cathedral quiet of observatories, where the most sensitive instruments ever conceived peer into the cosmic abyss with electronic eyes that can taste light from the universe's earliest moments. The Hubble Space Telescope, the James Webb Observatory, and ground-based arrays scattered across Earth's surface work in concert to map the invisible architecture of space, revealing structures and phenomena that exist at the very edge of detectability. What they have found challenges not just individual theories, but the entire framework within which we understand how matter, energy, and information behave on cosmic scales. Black holes, those gravitational monsters that Einstein's mathematics predicted, but his intuition rejected, have revealed themselves to be far stranger than early theories suggested. Some appear to possess masses that violate every model of stellar evolution, too massive to have formed from the collapse of individual stars, too perfectly distributed to result from random galactic collisions. Others seem to influence their surroundings in ways that suggest they might be connected across vast distances through hidden dimensions or exotic physics that operates beyond the boundaries of spacetime as we understand it. More mysteriously, some black holes appear to be information processors on scales that dwarf any earthly computer, their event horizons encoding data in ways that suggest they might serve as cosmic libraries or communication nodes for civilizations that have learned to manipulate spacetime itself. The holographic principle, emerging from studies of black hole physics, hints that all the information contained within a volume of space might be encoded on its boundary, a revelation that transforms our understanding of reality from a three-dimensional stage to a two-dimensional projection of unimaginable complexity. Galaxies themselves have begun to misbehave according to the careful predictions of cosmological models. Some spiral structures rotate too quickly for their visible matter to hold them together, suggesting the presence of vast quantities of invisible dark matter that outweighs ordinary atoms by ratios that make the visible universe seem like foam on an invisible ocean. But dark matter, itself a mystery wrapped in mathematical necessity, fails to fully explain the observed behavior of galactic clusters, which move through space as if guided by forces that operate according to rules we cannot fathom. Even more troubling are the observations of galactic structures that appear to align across distances spanning hundreds of millions of light-years, cosmic architecture that seems to suggest coordination or communication on scales that challenge every assumption about causality and information transfer. These vast filaments of matter form patterns that echo biological neural networks, as if the universe itself possessed a nervous system operating through gravitational channels that connect distant regions of space in ways that our current physics cannot explain. Light itself has become suspect in this deepening cosmic mystery. Observations reveal that photons occasionally vanish during their journeys across intergalactic distances, disappearing in ways that cannot be explained by interaction with known forms of matter or energy. Some researchers speculate that this light might be absorbed by structures existing in higher dimensions, while others propose that photons might be transforming into exotic particles that we lack the technology to detect. The very constancy of physical laws, long considered the bedrock of scientific understanding, begins to seem more like a local phenomenon that breaks down at the largest scales of space and time. Perhaps most mysteriously, the cosmic microwave background, that ancient light from the universe's birth that serves as cosmology's Rosetta Stone, contains patterns that resist explanation through conventional models of cosmic evolution. Subtle temperature variations across the sky appear to encode information in ways that suggest either unknown physical processes or, in the most speculative interpretations, the influence of intelligence operating on cosmological scales. Some theorists whisper that these patterns might represent the signatures of universe engineering projects undertaken by civilizations so advanced that they have learned to manipulate the fundamental parameters of reality. Self, the accelerating expansion of the universe, driven by the mysterious dark energy that comprises more than 2/3 of all existence, presents perhaps the deepest challenge to our understanding of cosmic architecture. This invisible force pushes galaxies apart with ever-increasing velocity, suggesting that space itself possesses properties that remain completely unknown to terrestrial physics. Some models propose that dark energy might be the signature of parallel universes pressing against our own reality, while others suggest it might represent the waste heat of computational processes operating on trans-dimensional scales. These discoveries have transformed the Fermi Paradox from a simple question about the absence of alien signals into something far more profound, a meditation on the fundamental nature of intelligence, consciousness, and reality itself. If the universe operates according to principles that exceed our current understanding, then perhaps alien civilizations have discovered ways to exist and communicate through channels that remain invisible to our crude instruments and limited theoretical frameworks. Maybe advanced intelligences have learned to encode their presence in the quantum fluctuations of vacuum energy, in the gravitational wave background that ripples through space-time, or in the dark matter networks that appear to connect distant regions of the cosmos. Perhaps they communicate through manipulation of cosmic expansion rates, through the careful orchestration of galactic collisions, or through information processing systems built from black hole horizons and accessible only to minds that have transcended the limitations of chemical-based consciousness. The deepening mystery suggests that the universe might be far more alive, far more intelligent, and far more interconnected than our anthropocentric perspective allows us to perceive. We may be like microorganisms trying to understand the internet, aware of the data flowing around us, but incapable of comprehending the vast intelligence network that we inhabit without recognizing. The silence of space might not represent absence, but a form of communication so advanced that it appears indistinguishable from natural processes to observers who have not yet learned to read the universe's deeper languages. And so we find ourselves at the end of this journey through cosmic mysteries, yet drowning in questions that multiply like stars in the expanding night. The 15 chapters we have explored reveal not answers but deeper riddles, each discovery opening doorways to chambers of mystery we never knew existed. What if we have been asking the wrong questions all along? What if the Fermi Paradox exists not because the universe is empty, but because it is so full of intelligence that we cannot distinguish consciousness from cosmos itself? What if every galaxy is a neuron in a vast cosmic brain, every black hole a synapse firing thoughts across distances that make light itself seem slow? What if the dark matter that holds galaxies together is actually the substrate of consciousness itself, invisible mind stuff that thinks thoughts too large for us to comprehend? What if alien civilizations do not build cities on planets, but engineer entire star systems as living spaces? What if they have learned to exist as pure information, their consciousness distributed across quantum fields that permeate every atom of space? What if they communicate not through radio waves, but through the careful manipulation of natural laws themselves, adjusting the constants of physics like a cosmic piano to play melodies that span billions of years? Consider this. What if the reason we cannot find extraterrestrial intelligence is because we are already part of it? What if human consciousness is psi? Imply one note in a galactic symphony of minds. Our Earth, a single cell in a cosmic organism so vast that we mistake its body for empty space. What if our search for aliens is like a drop of water trying to find the ocean while swimming in its depths? What if time itself is artificial, and advanced civilizations have learned to step outside its flow? They might be watching our entire history unfold in a single moment, observing every human who has ever lived and ever will live as simultaneously present. From their perspective, our radio signals have not yet been sent and have already been received, past and future existing as equally real dimensions in a reality we cannot perceive. What if consciousness is not produced by matter, but is the fundamental force from which matter emerges? What if the universe is not a machine that occasionally produces minds, but a mind that occasionally produces machines? What if every particle contains a spark of awareness, every quantum interaction a moment of cosmic thought, every wave function collapse a decision made by the universe's vast intelligence? And what if the answer to the Fermi Paradox lies not in space but in time, not in other worlds but in other dimensions of existence we cannot yet access? What if alien minds exist in the spaces between thoughts, in the quantum foam that bubbles beneath reality's surface, in the mathematical structures that give birth to physical laws themselves? What if they are trying to communicate with us, but their messages arrive encoded in the falling of autumn leaves, the spiral patterns of galaxies, the rhythm of our own heartbeats? What if every sunset is a love letter from an alien intelligence, every quantum measurement a cosmic poem written in the language of probability and desire? What if the silence of space is not silence at all, but a conversation so profound, so beautiful, so far beyond our current understanding that it sounds to us like the absence of sound itself? What if we are not listening for alien voices but swimming in an ocean of them, each wave lapping at the shores of consciousness we have yet to discover? As sleep claims your consciousness tonight, ask yourself, what if you dream with alien minds? What if the boundary between your thoughts and cosmic intelligence dissolves in the darkness, and in that dissolution, you touch the edge of an answer so vast, so luminous, so transformative, that morning will bring not just another day, but the first day of a new kind of existence, one in which the question, where is everybody, becomes, how could we have thought we were ever alone? The universe waits, patient as eternity, for us to ask the right question, dream the right dream, open our consciousness wide enough to receive the answer that has been calling to us across the dark spaces between stars, since the first moment we learned to wonder why the night sky is full of light, yet empty of voices. What will you dream tonight? And who, or what, might be dreaming along with you?